Hi, welcome to this evening's edition of the Build Tech Talks. My name is Sjout Zaal and I will be your host for this evening. So this evening is called Edge Computing with Plans, Azure and Nuxt. And our speakers will give you an introduction to these technologies, and they're going to hook up their plans with sensors and empower them with Microsoft Azure. Wow. So if you have any questions during this session, please ask them in the chat and I will pass it on to the speakers during this presentation. So we have two amazing speakers tonight. We have Melanie de Leeuw and Sven van Stralen, who are both going to inspire you to do more with your plans. So hi, Melanie and Sven. How are you?
Hello.
Hello,
I'm good.
Sjoutje.
How are you?
Good, good. So I'm so curious how you came up with this topic. Can you tell us what the story is behind this session?
Yeah, definitely. So we started first, I think, with a small tutorial where we thought like, okay, we wanna know more about our plants, and we saw these sensors, these moisture sensors, and these kind of things. So we thought like, okay, we can make a nice a coding night session about this. This is something that we do at Capgemini, where we sit together and then start building some new crazy stuff. What we did over there is that we hooked up the sensor to a small Arduino device, and then eventually started connecting it to what is it called again? To Telegram, so that you can communicate with your plans. And from that we thought, okay, we can probably bring this to a next level, and then this came along.
Wow. So you're going to show us how you can bring that to the next level. Wow.
Yeah.
Okay, sounds good. Then the floor is yours. Good luck and enjoy.
Thank you.
Okay, thank you.
Okay, good. Well, welcome everybody. Let me first start the session. Oh, yes, here we go. Okay, so really good to virtually see you here. We will start with a short introduction with the whys and the whos. After that, we have a bit of a knowledge sharing session with a lot of concepts to discuss, but we really have to discuss them in order for you to follow us. But we'll keep it as short as possible. After that, we will tell you all about our architecture for this project, what we've used, what we could improve, and how we would see the future of some of the technology that we've discussed. If you have any questions, like Sjoutje said, please let us know in the chat and we'll find some time to actually answer them. Okay, so our introduction. Why are we doing what we are doing? I think many of you can relate when we talk about the sudden obsession with gardening during lockdown times last year. Suddenly, everyone had a moestuin, as we call it in Dutch, like a vegetable garden. Even the supermarket was throwing moestuins at us. So an herb and vegetable garden you supposedly can grow from scratch. As we speak, I have a giant box of seedlings in earth sprouting. I think half of them have sprouted wonderfully. The other half has fungus now. So it's an adventure. And so I actually have to repot some of them already. So yeah, during these times, we brought plants into our homes, our balconies and gardens. We cared for them like puppies, talked to them, even sang to them or danced to them, who knows. We tended to their every need, just to see their leaves dramatically hanging or turning colors when their moist levels were not up to standard, or because they got too much sun and did not want to live on. At times, it was very dramatic. Oh. So, turns out, plants can be a lot of work. And I think many people already knew that. It was sort of a surprise to me. Because we are busy people with 13 other hobbies to fill our time with, we created a dashboard. so that in one overview, we can quickly tell whether one of our plant friends needs some water, maybe a bit of sun, perhaps a cup of tea or a blanket, just to feel cozy and not dramatic at all. So we created this dashboard for a number of reasons. To take care of our green buddies, just like they do for us, because it is embarrassing to have plants keep on dying on us, and because we like to automate every piece of our lives. So in the coming hour or so, Sven and I are going to take you through our tech stack and architecture flow to hopefully inspire you to create your own dashboard. On the screen right now, you see the actual dashboard, or at least the front door to our dashboard. We're not going to open it yet. But first, who are we again? Sven, would you like to introduce yourself further?
Yeah, of course. Well, my name is Sven van Stralen. I'm a software engineer, architect, community lead inside Capgemini. We recently started something that is called the Agents of Code at Capgemini, which is a group where we try out all kind of new things, and we create all kinds of sort of coding events. I'm watching the Agents of S.H.I.E.L.D. I'm now at season 5. It's a very cool series. If you're a Marvel fan, you have to watch it. I didn't do it yet, so yeah, shame on me. So I'm doing it right now. If you're around on Xbox, definitely you can hook me up. So and we can play together Destiny or Fallout or whatsoever. And for the rest, I do some DJing, mountain biking. And of course, working with Arduinos and all these magical chips, it's kind of became an addiction instead of a hobby. Yeah, that's basically me. Melanie, how about you?
Okay, so I am Melanie de Leeuw. I also work with Sven. I'm a front-end developer and also a member of Agents of Code, which is very cool. I've been with Capgemini now for 2.5 years, I think. Time flies when you're having fun, definitely. I'm a bread baking enthusiast, but I'm not really good at it yet. I'm playing through all Assassin's Creed in order, and it's already taken me like 7 years. I'm officially on number 5, but I started Valhalla as well because it's new and shiny. We recently bought a boat and I'm learning how to sail, and I'm also not very good at that yet, but here's to a very sailing summer this year. I like to take pictures of animal friends that I meet. As you can see, every holiday that I go through, I have this really nice camera with an incredible zoom function, which gives me the opportunity to make these kind of pictures, which I really like. And I live in Diemen with my partner and 2 guinea pigs who are in the left top corner, if I say that correctly. So yeah, that's a bit about us. But now we have to start with our knowledge sharing session. So just, grab a drink, just sit back and relax sort of, but also take it all in. It's going to be a lot, but also very fun. So let's start with edge computing, our first buzzword of the day, of course. It's not a new technology at all. There are already articles in 2017, and edge computing was called to be in its early days. So it has existed for quite some years already. But the usability of edge is growing. Its applicability can be seen more and more around us. I'll show you later on where, some examples where you can actually see it. But let's go for a brief history and fact sheet of edge computing. As you may know, cloud computing is the on-demand availability of computer system resources, like data storage, computing, and networking. It basically takes care of most of your computer needs and invites you, the user, to use it as much as you like without doing all the actual heavy lifting. The cloud is built on a model of highly centralized resources, set up with the idea that it should be available to and shared with everyone. Now, quick side note, of course, I'm not going to go into all the specifics because it's simply too big and it's not cloud talk, But if you're interested, I highly recommend just checking out what it means and what it can maybe do for you. So we talked about cloud. Then we have Edge on the other hand. It's built on the edge of the cloud, so to say, which basically means as close to the user as possible. It's built on the idea of a distributed, decentralized architecture to bring the core building blocks like computing, storage, and networking to the user, aka you, instead of a centralized place in the cloud. The ultimate goal for this new cloud flavor is minimizing latency for the users by bringing the public cloud capabilities to the edge, or in other words, as close to the user as possible. So it's not a replacement of cloud, not at all. It's not an either or, but a part of what the cloud is. It's an extension. So on this slide, you can also see that we also have the fog flavor. I'm not going to be going into that right now because, like I said, it's going to be way too big. But yeah, if you're interested, definitely check it out. So where can we find it around us? Well, apparently it's everywhere. I did not even know that. At its simplest, it's the practice. Edge computing is the practice of capturing, processing, and analyzing data near where it is created. So it could even, if it's applicable, take appropriate action. So you can imagine that there are a lot of possible use cases for this technology. Our smart devices are one example. The smartwatch on your wrist, or mine, I'm not wearing it right now, but it's there. Or smart home speakers like Google Home or Alexa, or as you will see, any number of IoT or smart device can make use of Edge to make the most up-to-date data, to get the most up-to-date data and process it immediately. Which is also why there's sometimes a delay when you're using your lights. For instance, if you have smart lights, there's sometimes a delay when you push a button and the light is actually going on. And that delay is what cloud providers are trying to minimize. Or when you ask a question to your Google Home, for instance, then you sometimes have to wait really long to ultimately be disappointed because she didn't understand you or didn't hear you or has some other excuse to not, provide an accurate answer. But yeah, so, but also try to imagine how edge technology can fit into the world of robotics, for instance. Machine learning together with IoT has been one of the prime fields in which edge is utilized. So that's extremely cool, and it has so many possibilities. Some other cool examples of where edge might fit, just to, give you a bit more background or context. For instance, in the agriculture sector, companies rely on thousands of sensors to monitor farm conditions. Sort of like what we do today, but on a slightly bigger scale, Media companies needing to optimize live or on-demand video. I can think of, the Eurovision Song Festival, that there might be a use case somewhere. And last but not least, definitely not least, it can play an important part to prevent catastrophic failures. I shut down industrial equipment or entire plants, the other plants, for instance. Then we also, as you can see on my slide, we have wind turbines. It sort of works the same as with the sensors. Like if something happens or something malfunctions, then you have to know it immediately. Otherwise, the entire point of that wind turbine is moot. So, that's just a tiny bit of context to what it all can do. It's everywhere. Ow. And as Sven will tell you next, the Azure services you can use to explore this cool technology are ever growing.
Yes.
Sven?
Yeah, here we go. My slides now also there. There are quite a few Azure capabilities already around edge computing. A few I will highlight a bit more than the ones that I have here on my screen. So I'll get to that. But just to have it a bit quickly, the Azure Ad Zones, that is basically where Microsoft and other parties are working together to get it to work more closely. I'll get to that a bit later. The Intelligent Edge is basically where you want to use edge computing to do all kind of AI things to figure out or immediately detect anomalies or whatsoever. Well, IoT Edge, where it stands for, of course, Internet of Things, and then we do some edge computing around that. And you could combine a few of those things to eventually figure out, for example, okay, I need to water my plants on this moment, and maybe an AI can decide on that, and then you can combine those two. Well, Azure Stack. If you don't have, if you're working in a big company, you will probably want to use hardware as a service. I will show you some cool examples there as well. Well, Azure SQL Edge, you might have guessed it what it is, a database on the edge. And the Azure FXT Edge is basically like a NAS, network attached storage, where you have that on the edge and then they can sync it together in the cloud. Then you have Azure Percept or Perceived. It's now in public preview. That's basically, let's say, almost the intelligent edge, only then for non-developers. So if you don't have a very big technical skill, then you could do there with some drag and drop to build there kind of an AI or for your edge devices. And of course, Azure Front Door. This is a different kind of edge where I will go into later. So yeah, here we go. The Azure Ad Zones. So what Azure is trying to do, they do it themselves, and you can do it as a private operator or whatsoever, or as let's say Vodafone, which now is not doing it, AT&T, because this service is now only available in the USA, and where they basically they already start there building these edge devices with 5G. Let's say not all, especially so for our country, the Netherlands is quite small, so probably we can have a reception. But let's say if you have a big company as the USA and a farmer that has like thousands of acres of land, and you want to have some information about plants. You don't want to walk that, you want to know it already, and then you want to place some sensors there and then maybe connect them with 5G or something, and then read the information. And there's these capabilities are for, and Azure here works together with all kind of telecom providers. I hope to see it also eventually here in the Netherlands. Then we have Azure Stack. Well, this is basically where you can get yourself some Azure edge devices. As you can see, it's quite high, powerful things, wherein the Pro is basically one for the rack spaces. Then you have the Pro R, which is the smaller one. But it can also have as an option a UPS, and the Mini R, which is basically backpack size. So that can probably be used like with mixed reality or these kind of things. But what we will use today is a super high performant Raspberry Pi 3B with 1.2 gigahertz instead of the one NVIDIA GPU high performance thingy, and a Node MCU with the ESP8266 with an 80 to 160 megahertz. So as you can expect, we won't be doing a lot of super AI things basically because we don't have the processing power to do it. But the devices from Azure does. Then if we look at IoT Edge, what basically happens here is that so you have these small devices that you have, or let's say a machine that who's building a car or whatsoever. They send in all kind of information. We call it the telemetry data, basically, and that can then be provided to an edge device, which is in this case then the Raspberry Pi. On this Raspberry Pi, we run some edge modules. That are those over here, the one of telemetry, insights, or actions. And then from there, you can already start deciding if there is something wrong, should we turn it off or should we turn it on or whatsoever, and do something with it. Where then eventually what we send to Iot Hub, where I'll talk about much more in this session, can be then just some status information, and then the decision has already been made, instead of having this round trip where you say, okay, this device sends it to Iot Hub, and then the decision comes from Iot Hub back to this device. This is a longer string than if you would do it on your edge. Then you can be inside your network. Then the Azure Front Door, which is basically a cloud delivery network. And I think some of you already know, but if not, I'll explain. It's content delivery network, by the way. Sorry for that. Basically, what they do is that Microsoft created these own edge locations already around the world. And especially with front end and with the assets that we share around, we want to cache that then on these kind of places, because then if someone, let's say, far away, so we live in the Netherlands, so we host all the stuff over here, but then someone in the USA needs to get our data. The first one, it will be transferred through this line, so that takes a bit while, but the rest, whenever someone joins, then we'll get the information which is cached already over here, which gives a huge performance boost on your website. LinkedIn, Jonathan Sorensen has been using a front door already from the preview state, and they're very happy to use it. And we will look to it a bit more later in this presentation. So, and then I'm going to give the floor back now to Melanie to talk about a bit more about server-side rendering.
Really nice, Sven. Thank you. Okay, maybe everyone's favorite front-end part, of course. But we're just quickly going over to explain what server-side rendering is. Also, you might see a tiny dash in between server and side. That's just that I just learned that it does not have a dash naturally. So my apologies for that. Okay, so how does server-side rendering fit into the bigger picture that we are trying to paint? When you're building an application, for instance, a website, there are a few rendering possibilities. Usually, you can choose between client-side rendering and server-side rendering. With client-side, the rendering of your application starts when a user goes to the browser. So you type in a URL. Then the browser knows it's his time to shine and will start building up the HTML and the CSS. And after that, leisurely start compiling the JavaScript. It might even throw in an API call somewhere. And before you know it, a fair amount of time has passed you by. Your tea is cold, sadly. With server-side rendering, you're rendering web pages on a server and passing them to the browser as an already formed bundle of your application. Your HTML is compiled on the server. API calls can happen on the server. Your website is being loaded, and the first thing it needs to do client-side is compiling the CSS. So here we've made a quick, well, not we, Sven in the past has made a quick overview just to visually and very easily explain the difference between client-side rendering and server-side. So on the client side, you start with parsing the HTML. but HTML cannot be shown until the CSS has been parsed as well. Those are the rules. So for those two, first both need to be passed. All the while, the user has already typed in the URL, pressed enter, and now just has to wait. For the functionality of the app, we are dependent on the JavaScript. And when all that is said and done, we might do some API calls because we love data. But as you can see, time is passing, things are being parsed, and only on the last screen during your API call, the client side will actually hand you your application. It's done. You can use it now. Have fun with it. Then you have server side. And you might already notice from our tone that we are fans of server side always. Even though I promised not to pick a side, but I might have done that. The API calls that we have to do, the HTML and CSS, everything will all be rendered with the JavaScript. The bundle will be handed to the browser in a neat little package. So it starts off with your API call, which can be one of the most time-consuming things ever. Then you have your HTML and your CSS, and that's all been handled on the server side. So whenever a user types in an URL and the request goes to the server, everything will be done, bundled, handed back, and there's less time in between the sending or the requesting and the sending it back, if that makes sense. So essentially the differences. Server-side rendering can be quicker, but it might also ultimately give you a bigger payload from the server to the browser. Because the bundle is already formed before entering the browser, SSR does have some SEO advantages over client-side. So of course, this is just a very quick overview, just the tip of the iceberg, because different applications can and will require different ways of rendering. Then, I'm mentioning Vue because we've made our application, well, not in Vue, but something that was built on Vue, and also because we love Vue. But you can mention any framework here really, because the same goes for instance, Angular or React. But how does our Vue application fit into this story, and why am I using Nuxt? That might be a question that you're asking yourself. So we're just quickly going to go explain how Vue renders application, and then followed by why we have chosen Nuxt and how Nuxt renders applications. So Vue.js is a framework for building client-side applications. By default, Vue components manipulate the DOM in the browser's output, but it's also possible to render the same components into HTML strings on the server to send them directly to the browser. How it goes shows this diagram. Basically, when a user puts in a request from a web page, like cool-page.com, which is a real page, of course. So the browser asks for content, the server serves back an index.html, and then Vue will inject everything that it needs to inject. So it is client-side because with your index.html, there might be some CSS files as well. There's definitely a JavaScript file. And then all its Vue components still have to be injected. So the browser requests the same from the server. The server gives back an index.html, like I said, and the browser is left to sort of just make sense of that. And he does that by rendering the style sheets and the script links. A server-rendered Vue app has its code run both on the browser and the client side. That is also possible within a Vue application and only using Vue framework itself. But of course, our next slide is going to be how can we server-side render a Vue app completely? First, I'm going to quickly show you, I think I'm going to quickly show you how a rendered Vue app, its source code, how it actually looks. Then I hope this works. Yes, it works wonderful. So we've used this this site from somewhere around the world. So if that someone is looking, thank you very much. And it has source code, which is just wonderful. I love source code. It's a Vue app. It's entirely built with Vue. As you can see here, it's probably too small, but believe me, it's a Vue app. So what Vue does, it renders your HTML, and I'm gonna just quickly scroll through it, because if you've ever created an HTML file, you know how it looks or how it should look. It quickly renders all its HTML. This is it, one div with ID app. And if you've ever created a Vue application, then you also know that ID app is just standard way of using that as your one entry point into your application. So it's rendered this. Fabulous. They have all these style sheets which also have to be rendered, but it goes next. But still, the browser would not be able to know what to do with all these assets or CSS files. It does not know what this does, because basically for HTML or a browser, it does nothing. And then the script or the build script is being injected, which also will handle all the Vue parts. So then at the end of the road or at the end of the line or whatever you want to call it, the browser will know, oh, okay, nice, this is Vue, so it's going to build up everything and Vue's there and it all works and it's wonderful. But that is something completely different from server-side rendering, which is why we've gone to Vue. Or to Nuxt. Right? Nice. So let me introduce you to Nuxt, if you don't already know it. It's a Vue-based framework. So every wonderful thing that Vue has to offer is being extended by a few other wonderful things. So it allows you to build static websites and server-side rendered applications. With Nuxt, there are right now 2 options. Their static site generation does not need a server. Nuxt will pre-render all pages and include the necessary HTML ready to deploy. In the server-side render mode, Nuxt will use a Node.js server to deliver HTML generated from your Vue component directly to the client instead of pure JavaScript. So I don't know if it was already clear, but we created a Nuxt app. And this was, of course, one of the reasons. So a server-side sends a fully rendered page to the client. And then the client's JavaScript bundle takes over, which then allows the Vue.js app to hydrate. A Nuxt app needs a Node.js server, and that server and its routes can be extended by middleware. If you are using Nuxt CLI, you can even get everything in a pretty bundle set up for you. But how does this work? And I hope this is a bit clear. So there's still a user who goes to coolpage.com. Instead, Coolpage is now a Nuxt app instead of a Vue app. So the browser sends the initial request to the Node server. Nuxt generates HTML and sends results from Nuxt's executed native functions back to the browser. The browser receives a rendered page from the server. And in that rendered page, so we're already in this part, because now it just sends back HTML. In this part, Vue's hydration kicks in to activate the reactivity. Basically, Vue is giving its all and adding to the already built, or let me say rendered, built is not the correct word, page to just make it better and do everything that it was supposed to do in the beginning, actually. So navigation is still done on client side, which also means that calls to the server will only happen during a browser refresh. Okay, of course, I also have an example of how that looks. Let me find it. So, okay, if you can still remember, this was our view app, you know, a lot of basic HTML, but would you know what to do here? No, I don't think so. I don't even know what to do. So if you have our app, our Nuxt app, which is also too small, but it's built on Nuxt. The thing that you see here, let me scroll all the way to the top, is a chaos. It's absolute chaos. It's not pretty at all. If you would hand this to someone, they would probably just fire you if he was a boss or she. This is just not acceptable, but for a browser, this is absolutely wonderful because it has everything that it needs to know. You see, we have all the CSS here, and well, I have to do a lot of scrolling because a lot of CSS, but if you scroll all the way down, there it is. Okay, then you have this tiny, tiny part with the body with all our HTML. This is it. This is all our HTML. And it's really small, but it's everything that the browser needs to know. And at the end of this line, I can't really show you, I think, because I'm not entirely sure where it is. But you have like 6 script tags for Nuxt, which means that whatever bundle of components and code that you made in Nuxt will be served at the complete end, but everything's already rendered. Like you already have an HTML and a CSS page. It's already pretty. A user can already, use it. So I hope that's a bit clear, what essentially the difference between client side and server side is. But of course, we have, I think, the main event now. Yes. So this is going to be fun. Nuxt Nitro was even in our title, but turns out that the only thing we did know about Nuxt Nitro was that we knew nothing of Nuxt Nitro. Absolutely nothing. So it's supposed to be the new server-side renderer of Nuxt, or even serverless renderer, utilizing edge computer in some way. So pushing rendering to the edge, as they say themselves in an interview. But this is a classic case for us of being too early, because Nuxt already fit our needs as a server-side renderer and being built on Vue, whom we love so much. Nuxt Nitro would have been the cherry on our plans. No, the cherry on top, to see how far this edge computing thing can actually take us. Like I said, we're too early. We could not even install their demo locally to maybe give you a glimpse. So maybe later this year, we can actually see whether Nitro could be the perfect fit for a planned dashboard. The screenshot that I've added to this slide are all tiny bits and pieces from the Vue.js conference early this year, or their NPM module, which has been, updated, I don't know, give or take 24 hours ago now. Let me see. Yeah, during February, they mentioned Nitro for, I think, one of the first times, actually. And here's just a tiny tidbit of what it could do. But since we don't have any context yet or documentation yet, it's a bit of guesswork, sadly. Okay, so what they do have, though, is a demo here, in which they, I think, utilize their Nitro. But because I still don't entirely know what it does, I'm not entirely sure what to point at. So yeah, there's a score thing here. We have a static page has been updated 1 month ago. And then we have a dynamic page, which is updated every time you go to that page. So I'm assuming that's sort of the Nitro part. And then there's also an API that explains to you that this is a tiny request, and this is a very, very large request. And that is one of the points that Nuxt Nitro also wants to give you. And I say here probably, so don't hold me accountable, please. But what they wanted to do was process requests on a per request basis. So not everything at the same time, not everything bundled into your starter bundle to hand over to a browser, but just every time something is being requested, it's requested with requests as small as possible. So that means that they also wanted it to start up quickly, cold starting. Only loads into memory what it needs per request. I also heard during an interview that it should transform an incoming request into a response that has some HTML or some other kind of response like JSON. So it has to be quicker than everything else. That is sort of your baseline. But it's an engine, right? So it's built for Nuxt 3. It's already in Nuxt 3. And the npm module that you saw on the previous slide is actually sort of like a backwards compatibility module for Nuxt 2, so that people using Nuxt 2 can already start exploring what Nitro might be. Not yet, of course, because it's not been published officially. So just to summarize what it might do, is that it takes your existing Nuxt server, it processes it with rollup, it removes or mocks dependencies that do not matter, and they've re-implemented a lot of node build-ins in a non-node specific way. So you're left with a single entry point, which looks at the request that comes in statically in advance and determine what route it might match, and then dynamically import the code to handle that. That was a longer story than I anticipated, but I got very excited, even though there's no info. So we were wondering if there were maybe already some questions that we could answer right now.
Yes, there are. Let me see. There are two questions. The first one is, what happens if we refresh the page in client side? Does it cache? The thing is that if you refresh the page, then of course the server responds again with the same HTML or whatsoever. But it's the idea that most of the time you won't be hitting F5 every time of your applications. So what actually happens is that you have this server-side rendered HTML populated, and whenever what then happens with Nuxt is that on the moment the JavaScript kicks in, it will make the website client-side. So on that moment, if you switch states or move to a different route or whatsoever, on that moment, it doesn't work as a server-side rendered application anymore, but just as a client-side rendered application. So it won't do a page refresh on that, these kind of things. And later in this presentation, I'm also going to show you a bit about how you can have some extra performance in there for, let's say, static assets and these kind of things, because then you could choose front door, for example. Then the next question. So with SSR, the payload gets handled by the server, and with the client side, the payload gets handled on the user's device. Well, that answer is yes. It's basically what happens is that you normally have these API calls. You do them then actually close to the backend services. when you do it with the client-side application, then your mobile phone in the train makes these API calls, and you don't know how the internet will respond. In the HTML way, of course, as well, but then you know for sure that it doesn't work, and then it will maybe show you just an empty app. I think at this moment these were the questions, and the only one is that I see is that I can't wait for Nitro. It's exciting stuff. Nuxt 3.2. I definitely agree on that one.
Okay, good. Then let's continue, I think, because well, time is flying by, like I said, because we're having so much fun. So what we're going to do now is we're going to put it all together. But first, of course, we have to introduce you to two very important, well, what do you call it? Living things, friends, buddies. We're going to introduce you to our plans. Sven, would you like to go first?
Yeah, of course. Well, this is the plan that we are going to use from my side. And this is the tenentity, if I say that correctly, also known as a prayer plant. It was a very little baby, and it's now quite growing. That's that's the plant we are going to use today. It's already hooked up, by the way. As you can see, some wires going on. Okay, Melanie, your plant.
Yes, I had to be very, very careful. Okay, guys, happy birthday. It's almost 1 year, I think. It's my first avocado plant. It's hopefully also my last, because they're very, very dramatic, like I said. But yeah, we've been together for 1 year now. Very happy relationship. I hope that I can someday plant it in my actual garden. Who knows, who knows. Okay, so those are our plans. Those are hooked up. So all the data that you're going to see from now onwards are from these plans. The next, I think, rest of the time is going to be split into 3 parts. We're going to start with data gathering, because that's where you usually start. And then Sven will continue on the processing and the app itself. But I'm going to first take you through the data gathering part. And as you might have noticed just now when we showed our plans, there was a lot hanging out or sticking in, or however you want to call it. So we've been using an Arduino, or specifically an ESP8266. Yeah, let's put it like that, which is just a tiny board that is able to read inputs using sensors and buttons, and turn these inputs into outputs, like turning on a light or sending a message to your phone, like we talked about before with the Telegram part. So it's not a computer, not even a single board one, but a programmable microprocessor. An Arduino generally only runs one program at a time, whereas, for instance, a Raspberry Pi can run multiple programs at a time. So that's just one of the differences. Again, it's just scraping the tip. There's so much more to learn about this stuff, but not that much time. It does also not have an operating system, which is another difference with an actual computer, for instance. You can tell your board what to do by sending instructions to the microcontroller using a special Arduino language. And in our case, we use C++ and an IDE that you can just download off the internet. So yeah, just a short intro into the Arduino. And this is the actual Arduino that you see on the picture that we've used. So if you want to, create our entire architecture flow, yeah, get this one. It's great. Okay. So we're using Arduino to receive inputs from our plants. First, we have our hardware on the right. We have a sensor to stick into the soil. We have a connector to connect the sensor to the Arduino board and our Arduino board itself, of course. So I don't know if you can see my mouse. I hope so. But this is our sensor this is the connector, and this is our board. In our case, we're using the Node MCU. So on the left side, you have our wonderful code, a bit of C++, and this is for the Arduino to interpret. It's not our actual code for this project, but that was way too long, and it would maybe take me the full hour to actually go through it. But this is the code that we used in our during our make session that Sven talked about before, which is basically just we start with declaring our variables, and then we have this setup function that tells which pins that we've connected, other pins to, which pins to interpret and use for input, basically. So from which pins does the Arduino has to get its input? If you can put it like that, I think so. Then we have, it says loop, but it's not entirely a loop. It's just a loop function. It's called a loop. And in that, we read the values of the input that the sensor pins give back to us the entire time. So there's also a conditional here. If digital soil equals 1, for this project, we're using analog soil. Digital soil would only give you back a 1 or a 0, which is not very, diverse. So we're using analog soil, which would also explain our numbers that you'll see later during this project. So then we have our IoT Hub and our Blob Storage. And I'm going to make this fairly quick because, it does what it does, but I'm going to show you right after this to actually get you maybe, give a better sense of what it does. So, it enables highly secure and reliable communication between your IoT application and the devices it manages. It can connect virtually any device. It connects you easily with other Azure services so that you can actually do so much cool stuff with the data that you receive. In our setup, we have connected 3 of our plans to the Arduino, or to our Arduinos. We've used 3 separate Arduinos for that as well, and connected the devices to our IoT Hub. In the code, you then specify this connection string to tell it, or to tell your Arduino to use Azure IoT Hub. You need a few extra Azure libraries for your Arduino to know how to handle everything, but that's basically it. Like if you want to connect your IoT Hub and your device with your actual Arduino, you have to tell it how to use the internet, use a bit of code, add a connection string, add some libraries, and lights go blinking, and there it is. So we also have a public GitHub repo with all the code that we've used. I'm gonna show it on the last slide, I think, but I'm sure we can also share it with you. So then we have our blob storage, and Sven is going to talk about blob a bit more later on. And like I said, I'm just going to show you, but basically what it is, it's storage. It stores a lot of the things that you might want to store. And in our case, it sends the data from the IoT Hub to a storage to store all our data in one central place, and as we specified, as JSON messages in certain batches. So this was phase 1, right? So now I'm going to actually take you through our Azure Portal. There it is. And luckily for us, I hope this is visible enough. I think I can just do that. Yes. Okay. We're going to start with our IoT Hub, which it specifies here which type it has, right? So that's cool. this is our resource group. This is where our resources live. If you haven't already met how Azure works or have not, been doing something with it, go do it. It's so much fun. So we have our plans hub. And I'm just going to take you through the things that matter for our project, because otherwise I would never stop talking. So what you would do next is register your IoT devices. Like I said, we have 3 devices, right? So if I click on Melanie plant, which is my avocado plant, I don't have a different name for it. You can see all these things here on which I am not going to click. But for now, we've just used our primary connection string to actually link it in our Arduino code. And then for all the other things, you don't really have to touch it. You could just leave it as is, and then that's it. Okay, great. That's part 1, right? You're registering your device in your IoT Hub. But the second thing is that you have to tell IoT Hub what to do with all the input that it's going to be receiving. Where to store it, where to take it, what to do with it. Like I said, we're using storage, a blob storage, for our device messages, and it has a certain endpoint just to link it. So if I click on there, let me see. Yes, so this is our route actually, and this is our endpoint. I'm gonna go talk about that in a few minutes. But they have a data source, and then we chose device telemetry messages because this is basically your log data of our devices. The readings of an instrument, that's what it's called. Then we have to enable this route for IoT Hub to be able to use it. You have to set your routing query to true. And okay, that's it. Okay, we've routed one route to an endpoint, but as you might have noticed, that endpoint did not already exist. Okay, then we have custom endpoints in which we're gonna actually specify what the endpoint is of the data that you're sending. So you click on that. And in our case, we have a storage account, planned IoT data, in which we have a planned IoT telemetry data container, because blob storage is usually made up of containers. We have a batch frequency, which is set to 350. So 350, I believe 350 messages is our maximum. That's going to be batched up. That's going to be sent. And then a new batch is created. We have a chunk size window. So even though this might not have been met, and this is met, just batch it up, send it along. Encoding, because I don't know what Avro is. I don't even know if I pronounced that right. I love JSON, so JSON is my go-to. Then you have a file name format, because there's structure. And that's just a set structure that you have to follow. Okay, and that was your IoT Hub. Then we go to storage account. And then I'll just quickly show you how our data is actually being saved. So you have planned IoT telemetry data in which our entry point goes to. And then we have, I'm just going to click on today on this. That's our second, well, no, these are all batches, so many batches. Edit. As you can see, these are all messages that our device sends us. Where is it? Where is it? Sven's plant. Yeah, these are all the data that our IoT Hub received and sent through our storage as sort of JSON, which is great. It's absolutely magical. If everything's set up right and works, it's great. So that was a sort of a quick overview of our first part. Are there questions?
I don't see any questions in the chat. The only thing that I probably want to alter is that the batch frequency is around milliseconds. The 350 is not how many messages, but how long it takes before it actually goes to store the data.
That makes more sense. Yeah.
For the rest, we're good.
So many things. Okay, well, we're still gonna have a few more moments for questions. So if there are any questions, we like to hear it. But I think Sven, I think you're up.
I see. I just got. I just see a question coming in. What do you actually measure? I guess the moisture of the earth. That's correct. We are doing indeed. We are measuring the moisture of the earth. That's correct. We have a moisture sensor hooked up.
And humidity and temperature actually, but it's so finicky that we're not going to mention what we are using actually.
Yeah, but I'll show that later. That's okay. Okay, then let's move forward. Why is Sven's plan sending so many messages? Oh, you have to know he loves me. That's why he sends so much. Okay, let's move forward, and then I'll explain more in a bit more detail. Let's see. Yeah, here we go. So so now that we have the connection with the Arduino connected to our IoT hub, we need to process this data. We need to do something with it. So as you can see here, this line. What we do here is that we store all the events that are coming in, basically. And in those events, there was a lot of extra JSONs, a lot of data being added. So when is the event, which device, and all these kind of information is being added. But what we also want to do is that we have some a live view. Okay, what's happening at this moment at this time. So first, to dive a bit deeper inside what's actually happening in there. So the IoT Hub makes kind of part of use of the Azure Event Hub. So with the IoT Hub, how it gets these events, it will use the Event Hub basically to process it properly. Well, actually to queue it. So the Azure Io Event Hub is a platform as a service. It's basically meant for big data. So that's why we are sending so much to compare a bit being big data. So this is then the setup that we create. So what actually happens is that Azure Event Hub, you can decide in how many partitions you have. Well, we have 0 and 1 at this moment, so not 1 and 2, but this makes it easier to explain. It's based on Kafka, so the events that they come in like in a Kafka way, and then these partitions. So we have these subscribers. That's, let's say, the event receivers. They can pull the events whenever they are ready to handle it. So that's also what we're going to see eventually in our function, that he will not immediately handle all these events, because let's say if we have all these devices sending every 5 seconds a message, or maybe even faster, we are doing it with 5 seconds at the moment. This Azure function, if it's a bit bigger than what it normally is, than what we are going to present, then it might not be able to handle it. So then the Azure Event Hub basically queues all these events, and there is of course a time limit to it. By default, it's a day. So if you exceed the time limit, then that event will be forgotten. But you can of course extend it or even make more of these partitions so that you have more of these queues and more of these receivers to handle all these events. But in our case, we keep it quite small. So what is Azure Function in this case? So these are the serverless computing power of Azure. They are event driven. Well, that's a good thing because we are getting events and sending it through. And so that is going to be our trigger. Then we have you can have an input binding. So let's take, for example, we want to add something, extra information or whatsoever to process it. And then eventually, of course, the output binding to put everything in there and to store it in a blob storage. Then I saw a nice question from Rinaldo coming in about why are you not using a database, or are you not maybe directly putting it to the app service? Well, this is cheaper at this moment. So we didn't have to do a lot to get this working. There is some latency, of course, but let's say if we have all these events immediately calling these services and all these computing power, then our app service becomes quite heavy. For let's say a professional, or when you move to an enterprise level of application, then definitely you should not store everything in a blob storage. That should basically be a thing for your files. You could you have different solutions to have it properly stored. At this moment, for what we are doing, just some JSON files, this was enough for us to make it work. So let's see this data processing stuff in action. Oh, that was a spoiler. So in the IoT Hub, we have that message routing. So Melanie already explained that it stores data to IoT, but we also have a different endpoint, and that's the events, where what we do is basically you could have a query that you say, okay, only a device of Sven or the Melanie plant will send the stuff to events, and the other one to something else. At this moment, we say, okay, just pass on all the all the telemetry data, telemetry messages to our Event Hub, and then we can subscribe to that Event Hub. And of course, we did that with some nice Azure functions. So as you can see, I have here one that's being triggered by an Event Hub. And then from that Event Hub, we basically process the data to create a nice own JSON where we have some live information about it. So the integration of it, I'm gonna make it smaller just to show you some cool arrows. So as you can see over here, Command R. That's too much. Okay. So we have this trigger, and then we do our compilation of the data, and then of course an output, and there we store again something to our blob storage. So if we and we have also some input over here where I'll explain it with the code that probably makes it better. I will zoom it in again. So what's actually happening is first I'm trying to get the device ID from the actually data which is coming in from the Event Hub. Then I'm also want to know, okay, from the input blob of my JSON, if it already exists and if the device already exists. Because when the device exists, what I want to do, instead of creating a new event, in this case, I just want to make a live view of it. So I just want to update the values which are already there. So then from the messages I get, I'm basically going to figure out, okay, is it one that doesn't exist? Then, okay, push one to my array. Else, update the device that's already there. And then I put actually that nice array, which is over here, just back to the output blob, and that eventually updates our JSON file in our blob storage. And I'm going to show you the blob storage real quick in Pliant IoT data. So basically what it does, it outputs this live.json. And in this live.json, you can find basically our devices which are connected right now. And as you can see, my test device just became drunk because it says it's 2 million degrees around here. I can say it's hot here, but 2 million is a bit much. But my Sven plant is giving a proper values at this moment, where the one from Melanie is also. Of course, we wanted to do also use Azure Functions to add Nuxt in there. With Nitro, this is possible, but at this moment we were not able to reach that. But I do still, or was able to create something where we could show let's say serverless server-side rendering. Only what I'm now doing is basically injecting the all HTML. So this is of course a quick and dirty way, but it does work. Here we can eventually, I'm responding with an HTTP. So if we go to that integration tab, the trigger in this case is an HTTP request. Okay, I get some information from our blob storage, and the output is an HTTP result. So, and if we see it, and let's check this in action, then we will see what it does. It basically gets this live data. Oh, yeah. Let me change this real quick. Create a new tab. And here we go. This is the information. My test device just woke up again. And if we then refresh every time, it would give me some new information. So let me see if I pull out this one. Is it going to give me a new result now? Hopefully Sven plant is not responding. Let's try the test device then. There we go. And here we go. Now he's all over the place. And let's put that back just to make him happy again. So that is how we now process our live data in this sense, because we also want to have some history, of course, and that's basically what Melanie was creating, because there all these events are being hosted. So yeah, that was basically that part. Are there any questions? Dimitri, it seems that JSON contains a lot of redundant data. Yes and no. There is for what we are doing, there is that's indeed true. For the parts where I think with the big companies, they probably need a bit more information, because you can also have like, okay, what's the state of this device and these kind of things. And IoT Hub also helps where you can actually remotely deploy stuff. But I'll get back to that later. And then if we move forward to part 3, the app itself. So we have our database, which is our blob storage. And we're going to hook up the blob storage to our app service, where we are hosting Nuxt. And then we populated everything to the front door. So what's the app service? So the app service changed logos. So this presentation has now both of them. It's basically a kind of a. It's not serverless, because there is still, let's say, as an Azure function, basically triggers, then boots up and does its thing. The app service is always ready. It's always there. So it's always running. And together with your app service plan, you can figure out, okay, how big should be your computing power. Where in the function, it's really pay as you use in kind of computing power. You can host web nowadays, also static web, mobile API, and of course just an API hosting platform. So you can use all kind of languages like Java, JavaScript, ASP.NET, Python, whatsoever, or even put your Docker container in there, and then you can give some special commands in how to run that. You can have variant of Linux and Windows platforms. And a cool strong point of the app service is that it makes the CI/CD deployments quite nicely. It put it all together, which I'm going to explain a bit more. When you eventually are going to use app service in a real situation, they already thought about blue-green deployments. So to have a zero downtime deployment, basically. So what they have done, they created these slots, and in these slots you can swap around whenever you have a new deployment. So let's say, okay, the production slot is now hot at this moment because everyone is using it. And then you can put it. You can put your newer version on the staging slot, and then gracefully start changing to the staging slot. And you can do it by a big bang, or you could say, okay, 10% of your users now move to the staging slot, and then 20, so that you can also use it as kind of production testing and these kind of things. So that's quite nice. They have all kinds of way in how you can provide your packages that has to be deployed. It can be pulled from a GitHub repo or whatsoever, or integration with Azure with CI/CD tooling. Or if you want to go wild, you can also use Dropbox and put your zip archives in there, and then it will sync it like that. I don't know if that's really a production way of working, but it's possible. Or of course SFTP. Yeah. So whenever you want, whatever you like, you can use that and make it workable. We have been using basically the GitHub pipelines structure. And then, of course, Azure Front Door, the content delivery network, which is not only a content delivery network, it does much more. You have also another one that is the application gateway. There is a difference between there because one has a bit of a zone redundancy. So there you have the regions where Front Door is basically on the Microsoft global network. So here you have more edge locations. Azure Front Door lives on layer 7, so the HTTPS layer, and from there it also decides on URLs where it has to go to. So as you can see in this image here, so whenever someone comes to coolwebsite.com and that is using Azure Front Door, when it does /star, well, it can go to an app service, where /static goes to a blob storage, and where /cool function in this case goes to an Azure function. So you can really decide on how that's going to work. You can have some SSL offloading on there, which is nice, easy, so you don't have to worry about it in your apps anymore. Or if you want to keep that secure, you can always do that, of course. They have session affinity, web application firewall, and it's freaking easy to use, and I will show you that in a minute. Okay, let's see how that then eventually works. So I will quickly, so that you don't see it. Yes, this was much faster, and so there is no spoiler now anymore. So first, let's look at our app. So in our app service. So what we have done here. Oh no, let's first go to the code. Here you go. This is much easier. This is much more interesting for you guys and girls. So we cheated a bit. Normally you would have, let's say, a real backend. But we created that also inside of Nuxt. So where we have in Nuxt, we do this server-side rendering. So we have our pages where it's basically a dashboard where we use fetch to get the data, and so whenever the first hit is made by the user, then it does a fetch to our backend where it gets the information, and then immediately renders the complete page. So all the HTML what you see over here will then already be in the source whenever you request this page. Inside the API, how we connect eventually to our blob storage is we use a node module that is called the Azure Storage Blob. It's a really easy module. I think everyone can do this. If you know a bit of JavaScript, then it's really nice and easy to do. So you have your connection string. That's basically your key to your blob storage. And then you can define actually your container name and the blob that you want to download, for example. So how do we download the blobs? Well, I have a function over here for that. So basically, first I'm creating the container client, where eventually you get the blob client, and then here you call blob client.download, and you're done. But then you get a stream, so you need to stream to parse that to a string. So created basically a function that first transforms the stream to a buffer, and from that buffer you can make it a string, and then it's downloaded. Which is then, if it's JSON, easily JSON.parse, and then you're done. If it's something else, then you probably want to do something else with it. But in our case, for our let's say live data, the live JSON, it was already JSON, so we could do just a JSON.parse. So we have a nice API call, get live data, which basically just then sends the JSON parsed live data. Whoops. Then for the history data, which is coming from Azure, it's a bit of a different pie. Because I can show you a funny thing there. Edge plant IoT data, where you think that you hit the mark of the Event Hub saying, okay, we now then populate JSON. Just get one random one out of mind, actually. I can tell you already, but this is not proper JSON. Why? It misses a nice comma at the end. And it misses the array. So basically, this line is JSON, and the other one as well. But if you download this file, then especially in your app service, then it's not yet JSON. So you need to do something for that. So what I basically did for that, so here we have my history data function. It's a bit bigger, where I basically first list out all the blobs, which basically gives you an not an array, but the thing where you call .next. I am lost in what it was, but maybe I will get to it later. But I was not able to use map, for example. So first, then I will find out, okay, which files I need to parse, put that in a proper array, and then from that array, I'll start basically splitting using the /n, so just mean the enter, and then I was able to parse basically the JSONs. So then you have a nice array with all your objects. From that, I'll start creating basically a same structure as what we did in the Azure function, where you add the information, and if the device was already there, then I'll just update the telemetry array instead of creating here a complete new object for it. Well, that's basically the connection between the blob storage to the backend of our Nuxt application, and then the server-side part. Well, that's rendered by Nuxt, so that there is not a lot to see over there. Only that we use a nice function called fetch, which does it server-side whenever it's requested as a new request, and when it did his hydration on Nuxt, it will move to the front end. So then back to our app service. To deploy, Nuxt, that was quite a struggle, because the documentation of Nuxt is not updated anymore as what you should do in Azure. But we found our way with reading some blogs and these kind of things. So we are using a Linux environment, and we needed to add some custom commands to make it work. We are using the Oryx build. Oryx is basically a build engine that they use for making this app service available. And why we are using Oryx build, because then you were able to do a custom build command so that you could use npm CI instead of npm install, what they were using. So, and for the rest, I have some environment variables, let's say production, of course, the connection string to our blob storage, which should actually be over here. But I found out later that this one was there. And of course, I put some hosts and these kind of values. But after using the Oryx build, then it started to work, our Nuxt application. Did I not forget something? Blob connected to the Azure. No. Oh, front door. Sorry. Yeah, I did forget. Then, of course, we want to use these edge locations of Microsoft. So we are using Azure Front Door for that. And as you can see, the location was already global. And then if you want to connect it, this is the only thing you need to do. This is the super easy way of working. So we have our domain, Kava app azurefd.net. Of course, you can make it a custom domain. Then you set up a backend pool. Well, in the backend pool is basically, okay, which are the apps, or what kind of services do you want to connect? And if that's done, you can set up a route. And for now, we have a really simple route, and it is /star. Of course, you can make it all kind of specific and all kind of special things. And if you want to add the caching, then you click on enable, and you're done. And you can even cache every unique URL, or say, well, ignore specified query strings. So let's say, for example, I want to ignore /API, and because that gives some always dynamic values, then you can use those kind of things. I've disabled it for now because we're still debugging and playing around with it, and else we have some cached information, and we already have faster performance with this. So now it's all set up. Then let's see what it's bringing us. And this is our Kava dashboard. So this is the application that we eventually then created. As you can see, our devices are doing things. So they are reading some values. We made some nice high charts just to have the fun with it. But I think the most funny one is the line charts, which is really going all over the place. Well, as you can see, my the Sven plant, that's actually the one over here. That device really stopped working. But my test device is doing a proper job. That's over there. And the one from Melanie is also quite stable. So let me turn on polling. So every 5 seconds, it will basically verify if there is some new information. And here we go. And then I will pull out the sensor. Then probably it will start flipping again. Oh, I even disconnected the sensor now. Let's put that back. Oops. And I expected already some results. Let's do a refresh then. Oh, and voice sensor. Oh, here we go. Yeah, okay, that was what I expected. So the polling mechanism doesn't work anymore, but okay, that's fine. But you get the idea. Again, it's 2 million degrees here because that cable just disconnected, and now he's all over the place. Ah, here we go. He's getting back. I will put the sensor back in the plant. And then here we go. Of course. Oh, here you go. Now it's a bit more, and then I know the values are what nicer. And of course, yeah, this then gets over the place, and that's basically the sensors that we are using at the moment. They are coming from a well-known website, AliExpress. So they're quite cheap, and they give very interesting results from now and then. So if I suggest that don't buy the DHT 2020 or for 22 or the DHT 11 sensors for your temperature and more and humidity, they seem to have a lot of issues. Are there any questions?
I think not.
Okay, well then let's move on.
Okay. Shall I give a quick summary then? And it's going to be really quick. So quick that you really have to listen, you know. So what do? We had our plans. We connected our Arduino, or multiple Arduinos actually, and an extra sensor. We registered that device in our IoT Hub. We told IoT Hub what to do with all the data that it got and send it through the Blob Storage. But during that same time, we also sort of activated the Event Hub to tell it when to activate the actual functions. Sven, please help me if I'm not explaining that entirely, but I think I got it. And then on those functions, every data that we, like, you know, what Sven told, we created the live.json file with all the latest data. So on one hand, we had our history part, and on the other hand, we had our, you know, most up-to-date data. And those were two parts that we did. And that all went into our blob storage. And then we went down, and then we had our app service, in which our Nuxt application lives, actually, is being deployed to Azure. And we're using front door as a CDN to actually make sure that whenever our users are, everyone can actually access this website with as minimal latency as possible. I think that's it for our summary.
I see that there is a question coming in about the costs. I don't know if we can switch screens because then you don't believe it else. It's at this moment €8 for let's see how many messages we have sent. Of course, it can be simpler. We wanted to test all these kind of cool things. Let's see how many messages did we send at this moment. Now we have sent 3,676 messages. So and then well, okay, we are using, of course, a free tier of IoT Hub, and if you have you take a paid version, you don't have this. Well, the quota is much bigger than 8,000. And of course, yes, the front door, if you're in the same country, is not required. On that moment, you could also then put it directly. But hey, if you're on a holiday or whatsoever, then you want to use this nice front door as well. Or you could use it, let's say, if you have multiple apps running on your same domain, or let's say have a static blog page whatsoever about your application, and you have then the real deal in an app service, then you could use that also to do. We did consider also Cosmos, but the pricing plan for Cosmos was a bit higher than the blob container. Else, I would definitely agree to move to a Cosmos DB for this.
Okay, let's continue with our last part because it's past 9.
Oh yeah. Okay, Melanie.
Yeah.
You're
Yes. Okay. So you can. Okay, my screen says good as well. Just want to say our code is in our repo, my repo actually, as Java public. So you can just go there, and all the code that we used, except for all our connection strings, are in there. So whenever you want to try it out or have some questions later on, just try to contact me because it's my repo, so it should be possible, I think. I'm not sure. So that's that. We learned a few things and we foresee a few things. We failed a bit as well. Playing with stuff which is not released and has no support whatsoever is a pain. I'm not going to say the rest. That's not, we should have known better, maybe. Who knows? But quite some documentation is non-existent or not up to date. So maybe for a tech doc, it's not super handy if you actually want to show as much as you can. But still, it was fun. It was a lot of fun to actually find out that, for instance, IoT Edge was, even though it would have been perfect for our purpose, not a great success yet. But I know Sven, so I'll probably keep on trying. And we also, Nuxt Nitro will become available later this year. So let's hope that also might answer some of our wishes that we have regarding Edge. We foresee the need for speed will become ever so important, not just for applications and user satisfaction, but also, think about all the examples that I gave about agriculture possibilities, for instance, or machinery possibilities, in which it's so necessary to get always up-to-date info, even if it can be life-threatening. So edge computing can and will be a solution to a variety of problems. And then we have serverless web apps and our CDNs. They are powerful, but its frameworks need to mature first. Yeah, like we said, we just couldn't even demo one of the things because we couldn't get it to work. So yeah, we need to maybe give it a bit more time, and maybe next year, who knows?
Yeah.
Okay.
And then we thank you. So I hope you all enjoyed it.
I definitely did. Thank you.
Perfect.
Great session. Yeah. So you made my life very easy this evening by answering all the questions yourself. Thank you for that. And there were some great questions about some different services that you can add. Really great. And what I heard from your last slide particularly is that there is going to be a part 2 of this.
I think for sure. I think we need to have a part 2. And that's basically when we improve the architecture once more. Because let's say that the app service has, so we want to make it a bit more even leaner and meaner, so that you could use the whole Nuxt inside an Azure function. That would be great. Then what we said in the beginning already was like that you then don't have a running application anymore, only on demand. So when the user goes to your app, then it actually provides the information what you need, and that you don't have a let's say continuously a server running. That's I think the next level for making this, and then together with IoT to connect it with IoT, which basically every time provides data. That's the challenge.
Yeah.
And the fun.
Yeah.
Okay, so
sometimes.
Then I hope that the both of you will come back when you have your architecture evolved further. Yeah, I'm very curious about part 2 then.
We can just skip over all the theory and just go straight into coding.
Yeah, you can just let people watch part 1 and then only coding for 1.5 hours, right?
Nice, that's the dream.
Exactly.
Okay. So thanks to the both of you. Really great session. And this concludes this edition of the Build Tech Talks. And this evening's and all future sessions will be shared on this YouTube channel. So if you're interested in more of this, please subscribe to YouTube or to our Twitch channel. And you can also sign up to our Capgemini digital meetup channel as well. And the meetup URL is shared in the description below. So thank you all for watching again and hope to see you next time. Bye-bye.